is a GraphQL meetup. But I shouldn't have used GraphQL.
In this instance, yes.
I'm Mitch.
Oh, take it over.
Okay, super. I'm Mitch. Been doing a lot of startups the last few years. My forte has always been Node, React, React Native. But recently I've been getting really into Elixir, and it's just an amazing ecosystem to work in that I'm really excited about. And I also like karate outside of coding. So yeah. So why are we doing this talk? Well, like the provocative title goes a little deeper than that. I don't want this talk to be, don't use GraphQL, or you shouldn't, or it's bad, or it doesn't work for your team. But for my last project, I realized in retrospect, I shouldn't have used it because it just doesn't fit the product that I was building really well. So that product was something called EEON. Back in June of 2019, I started working on kind of a stock portfolio tracking app for retail investors. And our hypothesis was, the Wall Street bets community would be really happy if we could do a lot of automated fundamental analysis and look at 10Ks and financial statements, balance sheets, all that stuff, and sum it up into a rating. And there were a couple types of ratings, A, B, C, but there was also the ability to index and say, Apple is in the 94th percentile for revenue growth and the 71st percentile for the tech sector. And it sounds kind of cool, but if you've been following the events of the last few weeks, you would know that Wall Street Bets is less of like fundamental analysis and more of like, YOLO, just bought 100 calls, GameStop, the whole thing. So just this last month, 2 months ago in December, we made the decision to shut EEON down because we don't want to chase something that's just not there. We never really found the product market fit that we needed. For a little context about the architecture, there were a few services, but this is the main service, and it was a Node GraphQL API that was organized into like the HTTP interface, a couple GraphQL modules, third-party integrations, a data access layer, which we're going to talk a lot about today, and then some scheduled jobs. And we use the common SaaS stack, Stripe, SendGrid. We had Postgres via RDS in AWS, and Elasticache, like a Redis instance for caching. And for the most part, like I'm pretty happy with this architecture, but it's the HTTP interface where like the GraphQL stuff really lived, and where I wish we had just gone with REST. We also had a bunch of different clients, iOS app, web client, we had an admin panel, Slack, built a Chrome extension. There were a ton of different parts to it. And even before this project started, I was a huge GraphQL advocate, just all about it. I had used the technology once or twice in a few smaller apps, and I was just really impressed with the auto documentation and some of the tooling that it gives you. And I was really a fanatic. If you don't believe me, I actually gave a talk in this meetup group about 2 years ago called Painless Development with GraphQL. And 2 years later, I've come to see the error in my ways and not thinking through all of the consequences of my decision. So, like I said, EEON like has to be GraphQL. There's such a great opportunity here to use it. When now I realize that wasn't entirely true. So sorry, if we look at EON for a sec, this is one of the main pages, basically an overview of how the market's doing. There's, you know, like the major indices, major sectors, some factors, stuff like that. And it just tracked performance, nothing too difficult. But as you click into each of these and click into a stock like Apple, you would get a whole universe of data. And that's kind of what this looked like. So I thought it would be amazing in order to run a GraphQL query to say, I'm looking at Apple, and not only do I want to see the price and percent change and, you know, some chart information, but show me the dividend history and historical earnings, insider trades, and then dig into those insider trades and say, like, how about this insider, Tim Cook or something? What are his other trades looking like? And we had all the data, and I thought this would be great to get just in a single request and be able to query it really smoothly. But like when I look at the product now, especially after a few iterations, does this query really make sense? You know, I was thinking a lot about depth of query and being able to see everything related to the related entities, Tim Cook's trades. But like for our actual EON app, how often is depth important? Spoiler alert, not often. Is this good so far? I don't see or hear anybody. People are...
Yes.
Okay.
Familiar problem.
Okay, super. So yeah, like not very often. For other applications, this might make a lot of sense, but EON was really about lists and looking at like very wide, shallow sets of data instead of individual data points and going really deep on it, which I think might be a better use case for GraphQL. And all of this is just like empirical, my opinion. I don't know, you know, maybe your team has a better way of doing it. So like with EON, we had all of these lists to the moon. Yeah, Wall Street bets. But we had all of these different lists that we tried to expose to people. And some of these were free, some were paid, but they were all very wide, shallow data sets. For example, if we look at 8 quarters of revenue growth, this is something that we pulled data for occasionally after every earnings, after earnings came out. And then we would run some background job every night to compute like who actually has 8 quarters of revenue growth and cache this. And all we're really caching here is the ticker, the company name, maybe a logo URL, and then the actual revenue growth, and maybe 8 quarters of it. I don't know, it differs for every list, but it's not really going deep. It's all about kind of breadth, not depth here. And you can see how the same thing sort of applies to the rest of these lists. If we look at highest cash positions or you know, near 52-week lows, you can see it's not a lot of data that we're looking to return, but it could be a wide array of stocks. Like when the market really tanked, you know, we might have had 1,000 tickers trading near their 52-week lows. But we didn't really need to show a whole lot of data about that in the list until someone really clicked into it. So like I said, kind of the workflow of EON and handling data was, this was a Node API, so we used this service called Bull, which was a Redis-backed job queue. And we would schedule these recurring jobs somewhere every hour, every 15 minutes, every day to kind of query our database and look at data that we had already cached and run some computations and just like cache the data that we needed to display to the front end. And then for the most part, the server was there just to serve. Request comes in, grabs some data from Redis, shove it right on back to the front end. Cool.
Can I ask a question?
Yeah, shoot.
I think you mentioned that you saved this data in PostgreSQL database, and like, was it deep in the database as well? Like, did you have like a lot of joins, or was it shallow in the database?
So I would look at joins as still fairly shallow because it's all normalized data, and you can you can join across those things without really having to traverse deep into nested objects. So like even when we had frankly, we never served data for the web app directly out of the database.
Okay.
When you were looking at stocks, it was always pre-computed and cached.
Okay.
So
that was my thinking here. Sorry.
Yeah. So we had to run joins when we were like preparing data to store in the cache to then be served later, but we never really did a lot of queries on the fly. For user data, yeah, but not really for like financial information.
Okay.
Yeah.
Okay. And then basically what you had cached, you could have just pushed out of the GraphQL server in a flatter format, but you chose it to be very hierarchical. Is that right?
Kind of. We'll get into that. It wasn't so much that like the hierarchy, we like transformed it on purpose into this hierarchy. It was just that we didn't need the hierarchy to really begin with, because the only data that was being consumed by the front end was like very shallow stuff. It would just be the ticker and the percent change. But rarely did we look at a list of 50 stocks and then say, on each of these 50 stocks, give me their earnings history. Does that make sense?
Yes. Yes.
Okay, cool. We could talk more about that later.
Thanks.
So yeah, recurring jobs would put things in the cache. The server was really just there to take it out of Redis and serve it. And this should have been my new acronym AFAP, as fast as possible, but it wasn't. And part of that is due to the GraphQL execution workflow. I forget what it's called right now, but in terms of queries, there's a parsing phase. And then when you're actually returning data, there's a validation phase to make sure that the data you're returning fits into the prescribed GraphQL schema. And that, does some null checking, type checking. And like that was a penalty that we paid, because what I really would have loved to do is just have a REST route where you hit the route and like a super thin controller basically that just like grabs the data from Redis and shoves it right back to the client. But we had to deal with all of this like data validation stuff, which really we didn't need. So like, I think that's the first part where I realized I sort of went wrong. And then it's like, so, all right, that's a weird decision for me to make. It was the wrong decision. But then where does GraphQL work? Just in my opinion, everyone's team does it differently. And you have all of the normal stuff with, bandwidth constrained applications, and it gives you really awesome parameter validation that you don't have to do manually. You just define it in the schema. And then this is where we sort of ran into trouble. The first is certain data. That means like, how confident are you that when you request your data, it's going to be there and it's going to be in the right shape and the right type that you expect. So there was like a good number of stocks that our data providers didn't have historical earnings for or upcoming dividends. So then what happened is we had to take these values in the schema, and instead of having really strong typing with non-nullables, we had to make those nullable. So we lost that a little bit of that type safety between the front and back ends, and we had to do null checking on our front end instead of guaranteeing that that data would be there. And I think this can work awesome if you have like a database with strong constraints and you're serving data out of that. But when you don't have a lot of confidence in what's going to be there, it makes it kind of tough to run this interface, and you lose a few of the benefits. The second one is, I think GraphQL is like amazing when you have uncertain UI needs and you need to expose data ahead of time. Maybe the back end is just running a little bit ahead of the front end. And you don't want to have this like back end dev, front end dev communication, flirting, hey, can you expose this extra field for me? It's great to just have that there, have it auto documented. But we didn't really have that issue. We had designed like 95% of our app ahead of time. So we knew what data we would need, and we knew what was exposed to us from our data providers. So we didn't need to like have all of the flexibility that GraphQL enabled. Like I said, it's interesting. I think it's maybe more suited for serving from the database because joins and stuff, we'll get into that in a sec. And then we tried using GraphQL subscriptions, and it didn't scale super well because we were really dealing with like machine frequency updates. We were getting pushed to us price updates on like 300 to 500 tickers per second during trading hours. And even with like some degree of filtering, that's still pretty tough to shove out over the wire to a lot of connected clients. So I think maybe subscriptions might work better for user frequency updates every few seconds, as the user clicks around. I think it can also work really well when you have different clients that actually consume different information. So for us, both our app and our web app consume the same information, and that could have been served just fine from a REST endpoint. But if you have like a mobile app and then a watch app or something that's really, you don't have the space to show that data, it can work better there. And then I think the biggest thing is just separate teams, because everyone knows like when you have a RESTful API, documentation can get out of date and it's hard to manage, hard to update. People forget, people get lazy, whatever. There's errors or it's incomplete. GraphQL, it's not with introspection. It's always up to date, and that can be extremely helpful. So I covered this, covered the uncertain UI. About serving out of the database. In RESTful land, it's very possible that you're running database queries and joins when you don't need them. If the front end is only consuming a certain piece of information, then, another client consumes this entire object or this entire relation or something, you basically have to run that join, right? So that you can expose the same data consistently. Or you can use some sort of like fields query param and change your logic based on that, but that can get kind of hairy. So I think GraphQL is a great way to only run the necessary joins on demand if you're serving out of the database. And there's tools to help you design and plan this, like Join Monster, or I don't know, there's a few other ones, but we didn't need this. because like I said, all the data that our front end was consuming was already like in the cache. Separate teams, we talked about that. And then the hard GraphQL stuff, like at least in my opinion, in my experience, it's kind of hard to load and return the right data when you are not, following the strict data loader paradigm. And when you have like different shapes of data cached and in different storage mechanisms, it can be pretty tough. And that's what we found. I think GraphQL gets a little harder when you're going wide in big lists, in big shallow lists instead of deep, because not only like do you not really need the ability to query all the way down into your graph, but you have to deal with like pagination and other issues like that, which, there's limit offset pagination and cursor-based pagination, but it seems to be a little trickier topic in GraphQL with a little less convention around it than some of like the pre-built REST mechanisms. Like I said, we had a lot of uncertain data with nullables, and that was tough to navigate because, very frequently we were asking for data that was null. And if that is an array or an object or something, it requires a lot more coordination between your front end and your back end to still do that null checking, even though like GraphQL is supposed to help you and give you those type safe guarantees. Error handling. This was a big topic for us, and it's something that I don't know how well defined this is in GraphQL, but using the Apollo server library, which we were using, every time there was an error, even if it was like unauthorized or unauthenticated or something like that, they were all 500s. So you can't, the implementations might be different in different ecosystems, but we couldn't rely on HTTP status codes. So instead, we kind of had to come up with our own error handling mechanism that I'll talk about in a minute. Updates and graceful degradation is another thing that I found really tough in GraphQL, whereas REST, there's alternatives. REST versioned APIs, or you can add another endpoint or something like that. But with GraphQL, if you decide to, you want to change a field name or add another input parameter, or even change something from nullable to not nullable, you can run into issues where that causes the entire query to fail because it doesn't pass GraphQL's query parsing phase. And that's really painful, especially if you have multiple different clients. Just the deployment effort and coordination on that alone can be killer. Authorization is another thing that I found a little bit harder in GraphQL. I'll talk about that in a minute too. Logging is an interesting thing. Everyone's got their own opinions on it, but in REST, you can see what endpoints you're hitting. In GraphQL, you're always hitting the same endpoint. So like our logs for a while were not super helpful until I had to pull in another tool, namely Apollo Graph Manager, to be able to see what fields were being hit all the time. And there are some benefits because you can get field level latency information and see like the frequency that certain fields are being hit, but normal logging tools might not cut it. And then I was also the only developer for the most part on this project. So I didn't need a lot of the auto documentation and some of that tooling that GraphQL offers. And here's the really big one, is that for our data model, I had to write things in such a generic way so that you could effectively traverse our graph and request the data that you needed, because I was still in this like deep mindset instead of wide, that I actually couldn't really optimize the ways that I was hitting the cache, because everything had to be so generic to allow for these relations that I ran into some big issues there. Things just were not as optimized as they could be with REST, where each route kind of serves a single purpose. Here's an example. When we look at highly cached, like pre-computed data, let's say we had a GraphQL query that was like, give me the daily winners. What I would love to see is something in the Redis cache that looks like this on the left here, where it gives me like the ticker, the price, and the percent change. Everything lives in the cache, and I can just pull it out and shove it right along to the client. But like I said, with getting generic, we had to kind of do it a different way, where we would store references to other objects that were in the cache. And even with Redis pipelines and stuff, this is annoying from a developer perspective, and it's just not as efficient as it could be. You need multiple lookups, and then, like I said, we were getting data pushed to us continuously. So as we were updating this, it felt more painful than it should be to expose something that's pretty straightforward. Talked a little bit about this. Apple generally has good data, and our providers have data for it because it's so frequently requested. But for other symbols, we ran into a lot of cases where upcoming dividend was null, or upcoming earnings estimate. Those things were null, which just kind of like degrades the quality of the API, because you can't count on the data to be there. And we kind of lost some of the benefits of the GraphQL type safety promise. And again, that's just us. Like, other people that know what their data is going to be, this is a great thing. Error handling. So briefly touched on this, can't really use HTTP status codes, at least in our implementation. So what do you do? And this is kind of one of the patterns that we wound up coming up with. Let's say you wanted to request a stock. We actually had to go through all of this rigmarole of using union types to reflect like any potential error that could occur there. And then when you're making that query, you're either getting back the stock information, happy path, or you're getting back this very specific stock error. And sure, you could abstract that into like more generic errors, but then what if you have a special case? And all of these like cascading issues can really hit you and slow you down, because now when you have to query for this information and you're getting stock or stock error, your query becomes more complicated, because you actually have to request certain data for all of the different types that could be returned. And you have to parse that. You have to have different front end states to reflect whether you got a stock or whether you got an error. And in REST, like, you don't necessarily encounter these same issues. You might just be able to use an HTTP status code to trigger something on the front end, or have like a more well-defined generic way of handling errors. Whereas for this, for us at least, it felt kind of one-off. Updates and graceful degradation, talked a little bit about this, because if we want to change our schema and return a new field in the stock error, or change a field in the stock error, maybe we make the message an array of messages. if you do that without updating the clients simultaneously, you're going to run into errors where this entire query fails. It's not really like REST in that you can still hit the endpoint, maybe get some partial data or get, the server can return any sort of error structure that it wants. And yeah, the client might not be able to parse it correctly, but that doesn't cause the entire query to fail. So the GraphQL kind of opens you up to a different set of failure modes. Authorization, pros and cons here, because we use this library that was pretty cool called GraphQL Shield that allows you to kind of create declarative rules for who can query and access certain types of data, or you can even do it based on the data, but it can be a little opaque sometimes. And we had some special cases for us. Oops. Oh, crap. Can you guys still hear me?
Yep, we sure can.
Okay, this super weird thing just happened on my computer where the entire screen is frozen and my Zoom still goes on, but I can't do anything. I'm gonna need to restart my machine. This really sucks. I'm sorry. This happens like maybe once every 2 months, and it's really annoying. And I can't believe it just happened.
Yeah, man.
So would you guys mind hanging out for a minute? We're almost done, and I can come back in a few.
Yeah, sounds cool.
Okay.
No worries. Just making dinner.
Okay, Bill, that's cool?
Yeah, yeah.
All right. Sorry, everybody. I'll be back in a minute.
I was looking into that graph manager that he mentioned, and apparently they rebranded it to Apollo Studio. It would be, has anyone had any experience with that before? That's something that I might look into implementing.
Are we still on?
Oh, yeah.
Oh, yeah. Cool. Bill, should I get back into it a little bit?
Yeah.
We're almost done, I promise.
Yeah. Do
All right.
it.
Cool. Coolio. It's so annoying that just happened. Bill, can you enable screen sharing?
All right. Hang on. There you go.
I think we were about here in authorization. So can everybody see this?
Yep.
Great. So authorization wise, we did some interesting things. Where unauthenticated users were only, or unauthorized users, sorry if you weren't paid, were only able to see a subset of some of our lists, like I talked about. And that was tough to do with GraphQL. With REST, I feel that it's much easier to be able to only return a subset of data while also notating that, hey, this person is unauthorized. With GraphQL, we ran into some issues of like, how do you only return the top 5 and then also return some sort of notation or errors array or something of, hey, you have to upgrade to be able to see the rest without only relying on the client to do that. And that was kind of tough. Something that I struggled with for quite a while. Moving on, talking a little bit about the generic queries. When you're doing GraphQL stuff, you might run into the n+1 error. Has anyone heard of that? Hello.
I have heard of it, but don't know
Prefetch
context.
problem.
Prefetch.
Okay. Sweet.
Yeah, it's your prefetch issue.
Yes, Bueller. You're writing an application that is a blog application, and you want to fetch all of the articles, all of your blog articles, and all the comments on those. For each blog article, if you're not careful, you can wind up running an extra query for each blog. So that's n blogs plus 1. And this is extremely painful and can kind of bring your service to a crawl. So there is a generic solution for this in GraphQL from Facebook called Data Loader, which allows you to write batch load functions. But for me, like, this was very hard to reconcile with our cached data. So, you know, I think it can work really well for other applications, but I just had a tough time making this work. Eventually I got it, but it wound up with like data loader factories where I had to pass in certain configurations, and we had higher order functions, and it was just kind of a grind. So all in all, EEON served highly cached lists of uncertain data. And the main problem I had with GraphQL is I had to write so flexibly that it led to unoptimized caching. Shameless plug, EEON is done. We made the decision to kill it. So now I am looking around. I'd love to talk to people. I'm looking for some place that's really going to be the right fit now. And I know there's some people here tonight that I've been talking to, and I appreciate you guys for coming. And yeah, I hope I had something partially valuable to share.
Yeah, it's good stuff. I feel like, well, let me ask you, do you feel like others are running into similar issues now that, like, I feel like that's been a thing where we all got excited about GraphQL and now it's been implemented in production? Do you feel like other people are feeling similarly?
I've heard people have great experiences with it and harder times. The first time you implement it, it's going to be tough and you're going to run into N+1 issues because you just haven't seen, GraphQL operations. But I can't speak for the community at large, but me personally, I would think pretty hard about whether or not it's the right tool for any future projects. Do you work with it, Daniel?
Yeah, I guess I can show my video. I like when people show their video. Yeah, I do almost exclusively now. I'm a freelancer, have a very generic story of doing PHP, WordPress, and then now in the world of React the last 2-3 years. And even in that transition time, am doing like headless WordPress, put in using their REST API into GraphQL, which is very interesting and seems convoluted. But yeah, I do work with it, and I'm feeling similarly personally of like, this was great, and then now I'm like, oh, here are the reasons why to not use this necessarily. It's not a be all end all.
Do you have similar concerns or other things?
Probably similar, mostly with the sort of like what you were touching on there at the end. Authorization is, luckily the stuff I work with seems very rigid. Like there's an admin and then there's users, and that's nice. Some e-commerce contexts get a little bit different. Purchasers, not purchasers, but have accounts. But even then, that's still pretty straightforward. But I could see it getting hairy if it broke out from there.
We had a couple levels of users, which is where it really got. I'm sorry, like not different roles, but just free users, low-level subscribers, and high-level subscribers, and that's where it kind of got iffy. And we were able to write these rules with GraphQL Shield, but wasn't trivial. Yeah. Anyone else have pros or cons, good or bad experience?
We also faced the error handling issue, but well, haven't really implemented it. But like we have seen, like I've seen that you were describing this approach with using the unions. There's also this other approach of using path. So basically, instead of you would have to make it optional, and then you would, in a more high-level field, you would return all the errors in a list, basically with a path where it happened and such. But I don't know if that's really easy in the end.
So I believe path is what will happen by default in the GraphQL spec if you encounter like a real 500 where there's some sort of runtime error. It'll tell you like at what field or what query it went wrong. But I haven't seen it like implemented custom. Is that what you're talking about?
I haven't heard that word yet.
That's okay. Whatever. Yeah. All right.
But yeah, regarding with this 500, actually, I believe I have read. It's been a while since I was dealing with all of this, but I believe like that most of the GraphQL errors are actually not to be served as errors on HTTP. Like you would return basically a successful request, the status code, but then in the GraphQL you would say like an application layer error has occurred or something like that.
Right. Yeah, I've seen that too with like where every response implements like a response interface. that can have a success, true or false sort of thing, and then errors, and then the actual data. I don't know.
It didn't cut the cheese for you.
Yeah,
No. Okay.
not this time. No.
Mitch.
Like with the logging. Oh, sorry.
Oh no,
Go
that's
ahead.
okay. Go ahead.
Okay, so maybe one more last comment. Like you are mentioning that with REST, like logging is easier because you get the path. Basically, tells you more information of what happened. Like just a note on that. Like we were like with Sentry, we were using like this. I think it's called options or something. To like give more context about where on which GraphQL path things happened. I'm not sure.
Oh yeah, there's certainly ways to do it, and that's what we got through Apollo Graph Manager, where it actually tells you what queries are being hit and what fields people are requesting. But it didn't feel quite as natural to me as just being able to like parse through REST logs.
Yeah, I'm actually missing the experience with REST, so I can't really evaluate that. Yeah.
Oh, okay.
Yeah. Thanks.
Were you seeing a link or a relationship between the data mutation and the error handling?
Well, what's that, Dan?
Were you seeing a link between the data mutations that you're finding and also like the error handling, or are they separate instances?
I'm not sure I fully
So, like, it might return data that was maybe inaccurate according to your null, your validation, right? Your like, let's describe your visible data, your visible. I'm trying to describe this. I'm new to this, but I was just kind of curious. Just like when you describe data mutations, what is it that means to you? What does it mean?
data mutations.
You mentioned it earlier in this. Is it like historical data that's not accurate? Is that, and then it's combining it or using data, mix matching it? Is that what that would mean to you?
I think I understand. So, we would request data periodically from our providers, like market data providers, and then we would run our own computations on those to kind of come up with the user-facing data that was just stored in the cache. And for some stocks, we were able to run most of the computations, but maybe like 2 or 3 fields on an object would be missing. So that actually forced in the GraphQL interface to make those fields totally nullable for all stocks and all clients, even though it only affected a small subset. Is that what you're?
Yeah, that's all. I was just curious. I wanted to kind of dig into that because I was curious where you're kind of going with that. So.
Yeah, so I mean, in REST world, this wouldn't really matter. You could have, you would just take the data and return it, and the client knows that it has to handle potential null cases. But what I was kind of getting at is because our data was a little inconsistent, we lost some of the safety guarantees that GraphQL is supposed to provide us because we had to in order to deal with a few of these edge cases. And it just kind of lessened the effect of using GraphQL as opposed to REST.
Thanks, appreciate that. This is awesome. So I like listening into it.
Cool, good.
Can I ask on that point? So in REST, you will just return the data as some JSON structure, I assume?
What was that?
So with the REST, like if you had handled this with REST requests or REST, you would just return JSON structures and have nulls wherever stuff is missing.
That's correct.
And actually, like in GraphQL, on the JSON, it would probably actually look the same, but you don't have like this. I mean, you go to GraphQL because you want the strict typing, but then you have to drop it basically because you have no guarantee that there is actually data there.
Exactly, and that's why, that's part of the whole thing about why it didn't fit super well for our application, because we had to do the same thing that we would have had to do in REST, and we lost out on that benefit of the strong typing. Yeah, which was just a function of our data. Other people's is going to be different.
Mitch, I've got a question.
Yeah.
I know we've talked about live view in Phoenix a decent amount, and it seems like architectures like that, and just a little background, if folks aren't familiar with it, it's a framework where you write Elixir, in this case, on the server side, and it sort of looks like you're writing front-end Elixir code. What's really going on is that there's this sort of boilerplate JavaScript level that just sends diffs of the variable bindings back and forth, right? So it's an interesting system, and it relies on certain features of a language that, but is this like one of these cases where, do you think like GraphQL is like a response to like a very particular historical need, like a case where you're writing this sort of client side heavy code? It kind of creates the problem that GraphQL solves. Because I can't really figure how, like, I'm trying to see how like GraphQL fits into like, like a pedal stack or something. And I can imagine like uses for it on the server side, interestingly enough, but it seems like it sort of obviates it on the client side a little bit. So that's kind of the question I had for you.
Yeah. And for reference, the pedal stack is Phoenix, Elixir, Tailwind, Alpine JS, and LiveView. I see a lot of eyebrows.
It's a mouthful. It's a real mouthful.
It's basically building web applications with Elixir and Phoenix, just a different ecosystem. But I think, Eric, that GraphQL was actually created at Facebook in order to solve the over and under fetching problem, where in bandwidth constrained scenarios, if you're looking at a user profile and it only shows the first name, last name, and the avatar, don't also send back the age and the day that they joined, So it's basically let the client request what it needs for the UI, if that makes sense. But I don't know how it would really fit into the pedal stack. I don't see it as a necessity.
Yeah, and you know what? I think we're actually on the same page here, because that's sort of what I was thinking, was that it seems like that basically live view, and there's similar features coming up in other like web platforms, but it's kind of like live view seems to basically handle that problem for you by only sending diffs of the, by only sending the changes in the relevant bindings over the wire.
Yeah, that's right for live view. And then I think you see the same thing in like PHP with live wire, I believe it's called. And
yeah, totally.
Yeah, I mean, I think this like HTML over the wire instead of, or HTML over the wire instead of big JSON blobs is a really interesting approach that's making waves.
I'll mention with live view, so like with GraphQL, you have some really great like client side caching libraries as well. So if you're doing like a mobile app, you can fetch that data once. So for example, I built an app where they needed it to work, where they didn't have good cell signals inside stadiums. And we could build up and cache a lot of the GraphQL, both the data coming in and the mutations, so that way, like when we did reconnect to internet, we could send it back.
Cool.
And that's something live view didn't work for us except for on the web app, but we just had it live view go through and query from our Absinthe GraphQL.
And that was because of the connection you couldn't rely on. Yeah.
Right. Yeah.
That makes a lot of sense.
So,
Cool.
so you guys were actually hitting your Absinthe API from within your live view? Is that what you said?
Yeah.
Oh.
So it was still writing out like the GraphQL queries that we need, and then going through the resolvers and everything.
That's cool. And then within the live view, you were interacting with the Apollo client?
Yep. Yeah. It was just sending whatever query, like the string, the query string or whatever to through Absinthe. And
that's cool. For the rest of the group, like Absinthe is a toolkit for building GraphQL APIs in Elixir. And I know Elixir isn't the most popular language, but it is up and coming, and it's a really nice ecosystem to work in. So check it out. But
that also brings up the issue of server-side GraphQL, which is something I've thought about a lot, actually. Like, it seems like for like federating microservices, it's like I could imagine like whatever it is that's feeding your live view might be using GraphQL like within your data center. But I've never actually implemented anything like that, but it's crossed my mind.
That's interesting. Are you familiar with Apollo's federation concept?
Yeah, I read the docs on this like one time and a while ago, and then it all fell out of my head. But yeah, this is ringing a bell.
Yeah, it kind of started out with schema stitching and was like, well, if you request a certain field, you can basically delegate that to an API further down the line. And then I think it's evolved into this federation concept. And to me, I'm a little weary of it because I don't know what happens if one of your upstream services is down, because then how do you use the introspection query on that service and stitch their fields into your gateway graph?
Right. Good point. Yeah.
So I wonder if one upstream failure brings down the entire gateway. Anyone have thoughts?
Well, I didn't mean to get us too diverted into this corner of the conversation, but it's an interesting thought experiment.
Yeah, totally.
Carry on.
Bill, are you guys using GraphQL at your work?
So that's a good question. So at EEON, we are. Most of our services are REST, but there is one endpoint, which is the menu endpoint, that is GraphQL. And that enables KFC.com as of now to be able to specify, like the menu that they want returned, right, for their front end. So I'm not on that team, so don't think I'm like the creator of this or the expert, but in that case, it does work very well because it allows us to let our client, which is KFC, be able to specify, the depth of all the things they want from the menu to be able to specify, right? So to show on the website. So in that case, it works really well. But for the most part, like everything else is like REST based.
Mm-hmm.
So
out of curiosity on that, Bill, I know you're not on the team, but do you know if they implemented any sort of like query cost analysis or depth limiting in that API? Because that's something that's something I ran into on this project, where if we're looking at a list of stocks near 52-week lows. When the market tanked, that could be 1,000 stocks. And that's a super heavy payload to send over, even if it's just like wide and shallow. So that it was an issue I sort of ran into and found a way around it, but I don't think it's something to be ignored.
Yeah, I could see that. Unfortunately, I'm not on that team, right? That provides that endpoint, but as far as I know, it's working out well. But yeah, it is a mixed mash of REST and GraphQL that we're doing. So take that for what it is.
Cool. I wanted to add this too to the talk, like something I don't think I conveyed very clearly is that as part of the GraphQL request lifecycle, at the end, when you have your data that you want to send back to the client, GraphQL goes through this validation phase where if you have non-nullable fields, it's actually looking through the data structure that you want to return and ensuring that those fields aren't null. So when I brought up the acronym AFAP, I want it to be as fast as possible and just take the data from Redis and toss it right back to the client. On every single request, we incurred this validation penalty when we really didn't need it. And that was like conceptually, I never really got over that. And it was kind of frustrating to me. And it would have been a better suited for a REST endpoint.
I would assume that the validation takes only like a few milliseconds, while like network transfer times are, I don't know, 50 milliseconds or much longer.
Yeah, I mean, yes. It's just one of those things that kind of irked me, you know? Yeah, I mean, trade-offs, and it was fine, but it wasn't as efficient as we could be. And it seems like it just would have been a much easier route to go the other way. Yeah.
Any other questions?
Sorry, actually, one more question. You said when you like calculated the data from your data sources, you put it in Redis caching. Mm-hmm. What format did you put it? Like when you put it in Redis, was it just in some JSON format, I assume?
I really tried to take advantage of the Redis data structures. So I was using, yes, like strings, but also a lot of sets, sorted sets, and lists.
These are not very compatible with GraphQL, I don't know. Are they?
Yeah, I mean, I don't know. It depends how you pull the information out and like transform it to send it back. But for things that were just like cached and could live there and would refresh, it was normally just a serialized JSON object, which I would pull out, deserialize, and send it back.
Okay.
But for other things where we needed to rank and index, I used a lot of sorted sets. And that was good. I'm a huge Redis fan. But I wish I was able to just serve that data more efficiently.
So basically, if you had used REST there, you would have just taken whatever you get back from Redis and just pumped it out and not done anything else with it, basically.
That's probably right. Yeah, and it wouldn't have been like a true REST architecture with you know all the HTTP verbs and doing it like totally conventionally, but it would have been like ad hoc endpoints that just serve a very specific purpose. The other part of it is like with GraphQL, our implementation was only post requests, which are much harder to cache at the network layer, right? Like it's not so much a thing as opposed to using GET requests for data and using cache control or browser caching, and that could have been a more efficient route as well.
Okay, so you sent like no matter whether it was a query or a mutation, you sent everything through a post.
That's right.
And because of that, you didn't get like some of the, I don't know what the mechanisms are, but okay. Yeah, makes sense.
Yeah. Yeah, like we routed traffic through Cloudflare, which could have served as like a CDN for some of this data if we were just using GET requests, and we weren't, and that was a pitfall.
But you were only dealing with GraphQL queries, right? Not with mutations, because it was
also mutations.
Okay, and they would actually change stuff in the database then?
Yes.
Okay.
Yeah, so our user frequency stuff lived in the database, whereas our machine frequency stuff, the financial information, generally lived in the cache. But most of what we served was the financial information.
And that could have been HTTP cached, like so.
Yes, it could have, and it just could have been served more efficiently from the cache as well.
Thanks.
Yeah. Yeah. I don't know. And again, this is just all my experience and could just be spewing nonsense, but I wish in hindsight I had gone the other way.
So what about Facebook? Why do you think they're going that direction?
I have no idea. But I would trust that they've put a good amount of thought into it, and they have their reasons.
Is there any situations where you would use GraphQL versus REST?
Yeah, if I was dealing with like mainly user frequency data that was certain and didn't have a lot of inconsistencies, and I think there are plenty of benefits to it. If I was working on a larger team, because you don't have to deal with the documentation hassle, and yeah, I think there's a ton of use cases for it, but it didn't really fit very well in my stack here. But I've worked with it in production before and had good experiences with it. So, I'm definitely not discounting it. It just needs to be the right situation.
Yeah, like anything, right? There's pros and cons. So
Yeah, trade-off.
Yeah, it depends on what you need versus what you don't need. So yeah.
Yeah, and you said the meetup next time is Universal Data Graph on Type.
Yeah.
Is that Matt Tanner? Is he doing that?
No.
Oh.
It's actually
Interesting. He's one of their DevRel guys over there.
Yeah.
And we were talking a little bit about it, and he used to be like an architect at a bank. And we were talking about banks potentially adopting GraphQL and stuff. And it's kind of like, well, what works for your team at the time? And is the investment in switching going to be so beneficial in the future that it's actually worthwhile? And that just all comes back to like what works for your team now and into the future, and trade-offs.
Yeah, just like everything has trade-offs, right?
Yeah,
Oh,
totally.
You totally got to evaluate that every time.
Yeah, and you know, in my last talk, painless development with GraphQL, I had a tough time coming up with downsides of GraphQL. And I was naive, but hopefully now I'm a little less naive.
Cool. Any other questions or comments?
Thanks, Dan. Just saw his chat. I hope this was valuable at all, and you know.
Yeah, no, this was awesome.
I think it's validating to just like, maybe we all have some of these thoughts, and yet we're like, but we got to stick with the cool kid on the block. Maybe that's not necessarily the case.
Yeah. Yeah. Shiny object.
Well, I think it's a good solution for a very particular kind of problem. It's the question is, do you have that problem? You know? Yeah.
Mm-hmm.
Thanks, Mitch. I'm going to run.
All right. Thanks, Eric.
Take care.
Yep. You too. That's a good point by Taylor.
Turns out we're not all Facebook. Wait, I'm building the next Facebook, and I'm going to be rich. I don't know about you, but we need another social network, obviously.
Every side project.
Every side project. It's a to-do list or a social network.
Right. No, well, that's good. Thanks, Bill, for having me.
Yeah, thank you. Part 2 of your talk has been very anticipated, and you know, because you with the other talk you gave, you know, was kind of cool that you're giving of a follow-up now. So
yeah, I mean, that's the other thing. Like, I was interviewing today, and somebody asked me about like what would cause you to change your mind, and I was like, just give me a good reason. Like, you know, strong opinions help loosely.
cool. All right. Well, if no one has got any questions, then we could let Mitch get on with his day there.
All right. Thank you all. It's fun.
Thanks.
Talk soon. Bye.
Bye.